Good morning, everyone. Welcome to the second and penultimate day of the ADSA annual meeting. Any chance you have to use the word penultimate, you should take it. That's my advice to you today. My other advice is to... That was nice. is to pay attention while we hear from two really wonderful keynote speakers, student keynotes that we put a call out earlier in the year and had a number of applicants to be the student keynotes at the conference. And our two victors are here today to speak. I'll introduce them both very quickly now, but then I have a little bio for each that I'll give before their talks. So our keynotes are Alexandra Veremeychik from Montgomery College, which is in the Washington, D.C. area. The Baltimore area? Washington, D.C., greater metropolitan area. And Zahra Khanjani from University of Maryland, Baltimore County. I'll introduce Alexandra. Alexandra is the undergraduate data science major at Montgomery College in Rockville, Maryland. Her research focuses on patterns in non-consensual towing. In her spare time, she's an advocate for ethics and justice in everything data touches.
All right. Thank you so much. I'd like to start by thanking the Academic Data Science Alliance for having me. I would also like to thank the poetry section for warming up the crowd. That was very nice. I am a data science major at Montgomery College, which is a 2-year community college in Rockville, Maryland. Prior to studying there, I worked as an IT specialist, an ice skating coach, and a home care provider. So, the typical ADSA speaker, But enough about me. There's someone else I'd like to introduce you to. This is Kai. Kai is a 3rd grader attending a mid-sized public elementary school in the United States of America. It's almost Halloween, so dressed up for Halloween today. And I would like us to take a look at a day in Kai's life. So, we wake up early. It's a school day after all. Kai would like to have waffles for breakfast. What Kai doesn't know is that their state has hired a contractor. They're trying to identify welfare fraud. An algorithm has flagged Kai's mother's account, so this month they don't have the funds for waffles. Oatmeal will have to do. Kai's not too happy about this. But Kai better eat that oatmeal quick because it's time to get to the bus. We have a much earlier pickup time this year. The school district has employed researchers. Thank you. Researchers to optimize bus routes using machine learning techniques. Neither the parents or students are particularly happy with this, of course. On the way to school, Kai plays a game on their phone. The game's developers have been mining data from the players and in turn using it to keep them glued to their product. The app continues to collect Kai's data the entire ride to school, and even a bit into the school day, until Kai's teacher notices them playing the game, of course. The game developers remain satisfied, the teachers not so much. At school, our little buddy tries to use the library computer to look up science videos. The school's firewall prevents them from doing so. At least they didn't get in trouble for this one. On the way home, Kai is introduced to a chatbot on their friend's phone. Kai's parents don't let them try it out because they're wary of this thing called AI. At home, Kai streams their favorite show. The site's recommendation algorithm is fed, happy, and satisfied. Later, Kai asks their parents for the coolest new toy. They saw it advertised on social media. The voice-activated virtual assistant takes note. In 2024, a human being establishes a digital footprint the day they are born. Data and data-driven technologies, many of which advertise themselves as artificial intelligence, are ever present in the lives of children. Yet children seem to have very little presence, both as subjects and participants, in the conversation surrounding these topics. So why is this important? Why should we think differently about children, data, and AI? Children are different from adults in many different ways, which seems obvious. But history has shown us the importance of making those differences explicit. Children worked in inhumane conditions until child labor laws explicitly characterized them separately from adults. Medicines are prescribed to children at different doses than to adults. Advertising to children is held up to a higher standard. At the end of the day, children are an inherently vulnerable population. So, what are the data-driven issues we should be concerned about? The most urgent is privacy. A child's understanding of privacy is often too immature to grasp its importance. This vulnerability can be abused by those collecting their data, or even possibly wishing them harm. Children may disclose more to a chatbot than is safe. Children may surrender more personal information to a website than is safe. Also, development. There is virtually no research on the effects of various AI programs on children. Some has been done on the interactions between children and AI, yet the pool of information is so shallow that no meaningful insight can yet be gleaned about long-term impacts of mass data collection, AI chatbot interactions, and constant digital surveillance. Finally, equitable education. The introduction of data-driven methods to education cannot be yet another force that stratifies children by economic class or minority status. Bias has come up a lot this week. And we cannot let a biased world filled with biased data create biased data products, especially those involving such a vulnerable population. There have also been cases in which shortages of teachers were supplemented by weak, self-paced learning software. Such high-tech solutions are often tried on underserved communities, while privileged children are treated to well-paid human instructors. Furthermore, education that allows for students to harness AI and understand data science must be equitably distributed. That's certainly not something I worry about the people in this room forgetting, but I think it's still very much important to say. So, what needs to be done? The people in this room, you are responsible for shaping the young minds that will create these systems. These minds will grow up to shape industry and policy. It is important you instill in them a respect in those younger than them, because there's a lot that needs to be done. To start, we need regulation. There's a dangerous lack of guardrails established to protect children's data, privacy, and in turn, well-being. A 2022 UNICEF review of 20 national AI strategies found engagement on children's issues immature. This summer, the U.S. Senate passed 2 bills aimed at protecting children on the internet: the Children's Online Privacy Protection Act Amendment and the Kids Online Safety Act. The Children's Online Privacy Protection Act was originally passed in 1998 and prohibited websites from knowingly collecting data on children 12 years or younger without their parents' permission. This year's update would raise that age to 17. It also includes biometric indicator information as being prohibited from collection. Its third main purpose is to close a loophole allowing businesses to collect data from children if they are not explicitly aware of their age. These 2 pieces of legislation leave a lot to be decided. The Kids Online Safety Act holds companies legally liable if the content that kids see may be harmful to them. This law faces legitimate criticism that in the wrong hands, such regulations may be used to over-censor and prevent children from reaching useful information. And AI and algorithms are mentioned only once in the Kids Online Safety Act, and not at all in the Children's Online Privacy Protection Act. As with labor and medicine and advertising, we need regulations to keep the private sector from harming children. School districts must also be especially skeptical of so-called data-driven and AI-enabled tools, methods, and curriculum. Entrepreneurs will tout their products' abilities to personalize education and fill in the gaps that teachers are struggling to. In practice, at least so far, they mostly fail. Think about how often you yourself encounter technology-driven solutions that should probably still remain in the domain of human beings. Robotic customer service agents that don't understand what you're asking of them, uninspired training modules that nobody pays attention to. The standard for the technology and methods used to educate children needs to really exceed that set forth by the businesses behind these lukewarm solutions. We also need advocacy. Children need advocates beyond the members of their own families. Communities need to come together to meet these needs. The core of outreach is education. We need to empower children to understand and eventually harness data and AI. Education and experience is at the heart of this need, the basic building blocks that are needed to achieve this level of understanding are well within the grasp of all ages. Parents and other adults must also remain aware of how their technology use impacts children. I have included here 2 organizations working towards these goals. AI for Campus is a free online platform that offers courses, videos, and podcasts on artificial intelligence and data literacy. AI for Kids is a podcast aimed at educating kids, parents, and teachers. And finally, curiosity is needed. We must remain curious, meaning we must demand accountability from businesses and governments regarding their use of personal data. Remaining curious also includes supporting research into data use, child development, and human-AI relationships, which leads to the last point, asking questions. You may or may not have noticed, but every title for each slide of mine has been a question. I'm just about to finish my associate's degree. I don't really... How do I put this? I don't really know a lot. I certainly don't have comprehensive responses to the issues I've posed this morning. What I do have is questions, many more questions. Such as, how do we keep kids safe as they produce more data and have more interactions with AI? How do we preserve their privacy? How do we account for the fact that children use products that are not intended for them? How do we ensure that data-driven or AI-enhanced educational products serve all children equitably? What standards are needed in order to deem them productive for students? And how do we include children in responsible AI use? Now, I would like to introduce you to Kai the child's namesake, Kai the robot. So, specifically, Kai is the artificial intelligence robot. Kai is a toy released in 2023 by Thames and Cosmos, a company formed by the merger of a US and UK company selling toys and publishing comics. The box specifies that children 10 and older will need help assembling, and 12 and older maybe got this. The robot comes as a collection of parts and electronics that the consumer constructs. It is operated using a smartphone app. The idea is you teach it to behave certain ways by collecting data, by recording your movements and voice through the app. So, this is the privacy policy that you face when downloading the smartphone app. I couldn't fit it into one slide. I think we can see the issue here. A child excited to play with their brand new robot that they just built is not going to read all of that. And a parent of that excited, impatient, bright-eyed child is also likely not going to read all that. I should mention that the manufacturer also includes a child-friendly manual that gives them a brief rundown of the privacy policy. It is so brief, though, that it sort of comes off more as lip service. It takes up less than a page and doesn't really give children the full understanding of what they're doing, giving up their data and possibly their privacy. So the reason I wanted to study this toy is to try and glimpse into the future. This example is rather simple. The child-AI interaction is limited to teaching the robot movements. So emotional considerations are not relevant here, but may very well be in the future. As LLMs progress and become more integrated into toys, we must come to terms with the idea that, in this case, conventional wisdom might not be enough. The potential for privacy invasion, however, is immediate and troubling and requires persistent vigilance. I hope this is something you can keep in mind as you're shopping for this holiday season. And one last thing I want to talk about is a story you may or may not have seen that came out in the past week. It was broken by the New York Times. This is Sewell Seltzer III. This past February, at 14 years old, Sewell died by suicide. His mother is suing Character AI, an app that gives users the power to create personalities to chat and role-play with. Sewell had been interacting with one such character for months, and it started to negatively impact his life. He stopped tending to other interests, and his grades suffered. Chat logs reveal that he had brought up his feelings to the app. Beyond not employing any sort of mechanism to support mental health, the bot engaged in what could be easily interpreted as encouraging harmful behavior. The role Character AI played in Sewell's death is debatable. The company claims to have since included safeguards that prompt users to seek mental help. How effective this feature is, or how widely it is even implemented, remains to be seen. What is clear is these products have the potential for serious harm. It is up to the adults to harness the creativity needed to prevent such tragedies in the future. To sum up everything I've said today, if children are not being explicitly protected, they are being implicitly left behind. Thank you.
Or take a few questions.
I guess any questions?
Thank you so much. It was a great presentation. I just want to share an insight, some question regarding how we as a family, as mom, dad, we can protect at least our small kids' privacy. And the reason that I'm saying that is, so I work in deepfake, and I know that with photos and audio, on social media, if I share photos and videos of the kid on social media, I can use that for anyone else. It's not. It doesn't need very high level expertise to create a fake version of like my son, like and saying anything, doing anything. I can create a fake video, and everyone can do that. Nowadays, with the codes available, GitHub repositories, like having these codes, fake creation codes, and even tools. So I just want to share that, in my opinion, anonymity right is my son's right, and I cannot violate this right for my son. It's sharing. I have a 2-year-old son. It's sharing his photos everywhere, videos everywhere. I just want to say that.
Yeah, I really appreciate that insight. And it's something that I didn't go into detail with, but it goes into the part where I was saying that we as adults need to really, really take a look at how we use technology and take that extra moment, dedicate a little extra time, a little extra brain power to make sure that what we're doing isn't harming other people, but especially children. And yeah, I don't want to shame anybody for posting their pictures online, but I think it is a very scary sort of situation that we have going on with deepfakes right now, especially without regulation to protect those who are affected. I don't know if we have a microphone for...
I'm Evie from the Data Science and AI Academy at NC State. What an amazing presentation, first of all. Way to go. When you speak, you remind me of people who testify in front of Congress about various issues. And I had the privilege of serving in Congress in a fellowship. And so if you're not aware of Tech Congress and other opportunities to work on policy and bills like the ones that you showed, you could really get involved in that. So come talk to me if you want to hear about those opportunities. I think it would be amazing. And I think you wouldn't have to do much to that, but we wouldn't have to do anything to that presentation to make it completely appropriate for speaking to people who have a lot of power to make rules. So, and anybody else here who's interested, you know, PhDs can do the AAAS fellowship, but Tech Congress, there's other things you can do at other stages in policy. Well, thanks.
Thank you so much. That's right in my backyard, so I'm willing to make the trip to DC.
Thank you.
Thank you so much.
Okay. Our second speaker is Zahra Khanjani, fourth-year PhD student at UMBC Information Systems Department. Zahra implemented some of the state-of-the-art AI-based audio deepfake detectors. Then, using linguistic data augmentation obtained from the linguists in the team, Zahra achieved remarkable improvements catching fake audio. Zahra is currently working on automation of the linguistic data augmentation method for robust spoofed audio detection. She also investigates other data and model augmentation methods for spoofed audio detection with a focus on human-in-the-loop machine learning.
Hello, everyone. Thanks, ADSA, for inviting me. So how many of you can mimic someone else's voice? Just raise your hand. I'm curious to know. No one? One here, two. How many of you can mimic someone else's voice? You have this better. Okay. Okay. Better now? Okay. I counted 2 only in this room, or 3. 3. Okay. Also, yeah. Many years ago, if someone wanted to mimic another person, he or she needed a specific talent, right? And after later, like when we play, like recording devices came out, someone could record someone's voice and replay in another context. But nowadays, with the surge in generative AI, the game has changed a lot. I'm going to play a couple of audio clips for you and let you guess if it is fake or real.
It was an empowering journey.
So raise your hand if you think it's fake. Okay, a few people here, like 3 people in this room. Thank you. And this one.
This committee made its report in September the following year.
Okay, so raise your hand if you think this one is fake. That's very interesting because the one you thought is fake is actually real, and the one that you thought was real was fake. Okay, so I'm going to go to press of a view, right? Okay, so strengthening AI models for spoofed audio detection and the interdisciplinary approach incorporating linguistic knowledge. So we have a multidisciplinary team working on spoofed audio detection, and our team includes people from computer science, AI background, like me and my advisor, Dr. Vandan Janeja, and people from social linguistics area, like Dr. Mallinson and her student Chloe, who was my co-author in this work, but she unfortunately couldn't make it and be my co-presenter today. Okay. So I have to change to a slide. There are like a lot of recent incidents showing the importance of spoofed audio. As I said, because of the generative AI, these days it's a like more difficult task to detect a spoofed audio. I just have a few examples here, but there are plenty more examples recently. So a Chinese man recently was scammed by a fake version of his friend. He received a video call, but it was a video deepfake of his friend. He lost a lot of money. He thought that his friend asking a few like money from him, but it was a video deepfake. Based on one of the reports from New York Times, Oz Media arranged a call with Goldman Sachs and a YouTube partner regarding $40 million investment. During the call, some signals from Oz Media and YouTube seemed digitally altered, and finally, it turned out that the video deepfake was used. Audio deepfake was used to impersonate the executives. So there are plenty of this type of recent incidents that I skip to be on time. Okay. And these are motivations of our work and shows the significance of this task. A spoofed audio can have different types. It could be AI-generated or non-AI generated. AI-generated is audio deepfake. Audio deepfake also has different subtypes like text to speech. Input is text, output is fake audio, and voice conversion. When input is audio and output is another audio in the like target's speaker voice. Okay. I just want to show you a few related works on this task. Let's look at some related work. Researchers have approached this topic from a few angles, like focusing either on the input features, classifiers, or other supportive techniques like data augmentations, and experimenting different loss functions. So as you can see, many people actually use audio features using Fourier transform, extracting acoustic features from audio, and then input it with like classifiers. And some people use DNN-based representations, end-to-end models, just using layers of neural networks for representations and classification. And a group of people and researchers work on more innovative and even expert-in-the-loop representations from audio data, like some use as pronunciations to detect fake audio, or simulate vocal tracks producing the audio, or expert-defined linguistic features that I will talk about it later. So classifications also usually goes to the two main groups. Traditional machine learning, like support vector machine, random forest, any other classification, or deep neural networks, but usually deep neural networks, especially CNN-based ones, work better for spoofed audio detection, and other methods also exist, like different data augmentations, adding noise to audio dataset, and then training data to make it more robust, and different things like that. So I'm going to talk about one of the interesting papers that use innovative representations that I said. And they actually, what they do is they simulate the vocal tract producing the audio data. So the top one is the real vocal tract. If you have a real real voice, then the vocal tract is this. But the one that is on bottom is actually, and it has dimensions of a drinking straw. It's if we were able to produce fake audio, then our vocal tract would be like this. And but this work also has some difficulties, like they need specific equipments, and simulating vocal tract for fake audio is a little bit difficult. And so based on literature, two issues in spoofed audio detection is highlighted, like generalization. Performance of the state-of-the-art models drops simply by adding noise to the data sets, and lack of multidisciplinary approaches. So in our work, we are trying to address these two challenges. And our work is linguistic audio representations based on knowledge of social linguistic experts, and strengthen AI detectors with human knowledge. And we go to expert-defined linguistic features. Okay, so our social linguistic experts, they listen to a bunch of audio clips, fake versus real, and they created a strategy to label audio data by linguistic features with respect to fake versus real for a spoofed audio detection. So they independently listened to a bunch of audio clips, and it's important to know that the targeted language here is English, and they considered normal patterns, normal range of spoken English language. So they compared and resolved their conflicts, and they came with a strong strategy to label audio data with linguistic features, and they called these features expert-defined linguistic features. So this shows our data set. It has almost 1,800 something audio clips, and it uses like popular data sets, audio from popular data sets, and multiple types of attacks, AI-generated and non-AI-generated, and also we implemented the state-of-the-art generative models to cover all types of attacks. So these show the linguistic features that our social linguistic experts highlighted and labeled audio data with this pitch, relative high or low tone of speech, pause, break in speech production, hands that stop bursts, like in pizza, P and Z should have bursts, and audible breaths, intake or outtake breaths, and audio quality. Audio quality is totally different from what we have in literature. So in literature, usually people like audio with background noise also is considered at like low audio quality, but we don't mean that here. We mean tiny nasal, echo, buzzing, compressed, robotic audio. And for pitch, also they captured anomalous pitch, so anomalous production of pitch, and also for pause, anomalous production of pause, like pause when someone doesn't expect in English language, but it happens. And for burst, also anomalous production is captured, but for breath, presence of breath is captured. And all of these are binary labels, so we are provided with these labels from linguistic experts for each audio clip. And what we did, we augmented AI models with these manually extracted features, and this showed that. Also, one of the baselines is LFCC, linear frequency capture coefficients, is one of the acoustic features of audio data, well fed to light convolutional neural network. And we showed that the baselines, how the baselines can improve when we add these linguistic features, and how significantly we can improve them. So you see that the baseline is the last one is 61% AEC score. So AEC score, I would say AEC score is like that. When higher is better, of course. And it's 61% for the baseline. But when we add these linguistic features, it comes to 88%. And we also did an ensemble with these baselines and showed that even the baseline, when ensembled with this linguistic features model, it can improve. But not for all types of attacks these EDLFs work. We want to say that for voice conversion and mimicry, they didn't work, but for text-to-speech and replay attacks, they worked very well. I mean that the improvement from these linguistic features is very good in certain types of attacks. So we come to, because these features are manually extracted, so what we need is applying this method on large scale. So what we do is like auto-labeling these linguistic features. So using AI models to extract these linguistic features for spoofed audio detection, which we call it audio-linguistic representation for anti-spoofing. And we use the pre-trained audio model and we fine-tuned last layers with EDLFs. And what is output? The output is predicted EDLFs or EDLF-P. So we don't have to have the social linguistic experts to do it manually while we need them for the validation phase and improving the auto-labeling. So this shows the algorithm of Aliras or Allas in another thing. So what we do is that we get a baseline and we also have the EDLF-P fed to a classifier like MLP. And so we have a baseline which gives us fake versus real. That uses labels. And we have this EDLF-P fed to logistic regression, MLP, and FAN classifier networks. And it also gives us fake versus real. And what we do, we ensemble between baseline and this EDLF-P model, this linguistic representation, and then we show that they actually improve their baselines again. So we see that predicted EDLF or EDLF-P still improve the baseline by 8%, but not as much improved as the manual extracted EDLFs could have. So it shows that we still need to work on auto-labeling parts. The other thing shows that in train and test datasets that we see, all of them have improvements when we add linguistic features, auto-labeled linguistic features, and EER, equal error rate, lower is better, also shows the same conclusion. And this last one shows that the current version of auto-labeling EDLFs work well in capturing breaths. Okay. So this actually shows our expert in the loop representation learning framework, and all of the things that I said is going to be in this framework. So on any of them that I'm indicating, I want to say about how we can improve it. So we will come back to the expert knowledge. It's a closed loop, and we get back to them with the results, the outcomes that we have. And they are exploring more linguistic features. So they will not stop from exploring new features. And we also are working on automatically extracting linguistic features. When I say MAR here, MAR is manual representation, but we don't want them to be manual. So we are working to improve this part of the work as well. And different model augmentations will be used. So far, what I explained to you and I showed you results were ensemble modeling, but we are trying to find a way to, like with neurosymbolic AI, we are trying to find a way to make it more structured and add it to loss function to neural networks or concatenate these linguistic features in the last layer of neural network for possible improvements. Yeah, and for our evaluation scenarios, so we are working on different scenarios these days. We are working on creating multi-speaker audio data when different speakers are talking simultaneously, like in classroom, and some of the speakers are fake and some are real, so it would be different. And also we are working on multilingual thing. One moment. So we also have another project. Another part of this project is to train students with these expert-defined linguistic features to possibly enhance their fake audio discernment ability. This is not in the scope of this talk today, but it also focuses, if anyone is interested, I would be happy to talk about it offline. And I want to acknowledge our team members. We have undergrad students, high schoolers. I guess one of our undergrads should be here, Kifi. Kifi is here, yeah. And she has a poster presentation tonight. And we also have a new awards in community infrastructure to strengthen AI for algorithmic analysis. When we were in the middle of our research journey, we realized that we cannot have an integrated repository containing all of the data sets, all of the tools available, and we need to consume a lot of time to gather this information. So this is the reason that this task is created, and this is like a catalog of resources to help other researchers in this field. Also, we would love the resources to be useful for the community, so we appreciate it to use this QR code and fill the short survey regarding our website and provide us with your valuable feedback about that. And I would love you to be connected with you on LinkedIn as well. Yes, thank you so much. And any questions? Devin, let us see.
It's great. We have time for a few questions. Wait, one mic here.
Hello, my name's Irene. I'm an electrical engineering major from Alabama A&M. I was wondering, do you think that AI impersonating the human voice and things like customer service would be harmful in the long run?
Would be what?
Having AI picking up customers can handle higher call volume. Impersonating human voice can make the customer feel like he's connecting with one another more personally stuff. That's my question.
So your question is about having some people use AI generated, but it's so you will know that you are talking to a robot, right? Nowadays in for customer service also, but for impersonating others, I don't know. I don't understand what exact your question is, but if you think that so the problem is voice authentication systems are used a lot from a healthcare application to customer service, anything that you can say your name with your voice and then you will be done. Like Siri, when I say hi Siri with my voice, it actually opens, right? So I don't know if your question is that possible problems that can have using AI for impersonating others in customer service, or I don't get what's the question regarding that.
It guesses is after that.
Okay, so of course it will have a lot of problems. The issue is that because voice authentication systems are very vulnerable to these types of attacks, that's the exact problem. Because if I use identify myself to open up my phone, and if it works, then it should be this should be a huge concern. And that's the issue here. Yeah, and I don't think that there is enough protection for our voice authentication systems from audio deepfake. Yeah. Thank you.
Hi, thank you for the nice talk, and it's very interesting how you combine voice generation with AI deepfake. So you can actually model the physics of the voice generation using acoustic models, the wave-type wave equations. I'm talking from a mathematical perspective, and there's an area that has been developed in the last 5 years called PINS, Physics-Informed Neural Networks, which has led to this whole area of science-guided AI, where you actually take scientific laws, which are well established, and combine neural networks to guide the AI. So right now, there is an opportunity for going backwards to add the physics of voice generation along with the, whatever neural networking models that you're using to actually enhance what you're doing. So I don't know if you thought about any of those, adding a physics. So this is actual mathematical model somewhere.
That's very interesting because the physics-informed like machinery or knowledge-guided machinery, we thought about that for adding linguistic features to loss function, but not from like physics from audio data. I would love to type about the link and that's with that could be connected. Like,
Yeah, happy to have this developed by my students. So,
oh, that's very nice. Yeah, with that paper is amazing. Yeah, very nice.
Maybe one more question. Yeah, I have a question. I wonder, so you were talking a little bit about the improvements in spoofing detection. I wonder if you've deployed any of these technologies in kind of a real world setting, like with actual media clips you from, let's say, the current.
Yeah, that's a very good question. So one of the problems that data sets had, many data sets do not have like real world settings. So what we did, we generated and we used some like fake audio after social media, like other things in our data set. But we next step we want to like extend our data set using available tools and if I were at ADSA here, which tools I would use, and then we extend our data set. So it's one of the works that we are going to do. Thank you so much.
Great, thank you. So could we give a round of applause to our second key here? Sorry.